Hi guys, welcome to the next lesson sequence. We're looking at covalent bonding today. Let's get started. You're going to need the same resources as always, something to write with, something to write on, and you'll need your attention span. And as always, when we're doing these questions, pause the video, answer them all, check what you're doing is right. And if you're getting stuck on anything, need a bit of help, rewind, rewatch that explanation, okay? You might need to watch it 2, 3, 4 times before you're confident to move on. Periodic table for reference, rewind back and use it if you need it. And let's get started with retrieval. Okay guys, so far we've looked at ionic bonding, and that was between a metal and a non-metal. And the way they did that was through transferring electrons. So the electron was going from one atom to another one. Now it's going to be slightly different with covalent bonding. So we don't have any metals involved now. This is between just non-metals. And instead of transferring electrons, they're now going to be sharing electrons. Non-metals on that right-hand side of the periodic table. Okay, so let's have a look at an example. We'll start with hydrogen gas. So our first step, what we need to do is just write out the chemical formula, so similar to what we've been doing already, of what we're trying to find. So hydrogen gas is H2, and you're always going to be given that chemical formula if you need to write something out. So that little 2 next to the H is telling me that I have 2 atoms of hydrogen. So I can use the periodic table and do as we've been doing before, so I can find out how to draw it. Now hydrogen only has 1 proton and 1 electron, so it's nice and straightforward. But I need to draw 2 of them, so I've got 2 atoms. For the second one, I'm going to draw it with that circle. Again, just so we can show that the electrons are coming from different atoms. They're still the same thing, they're still an electron. Now this is similar in the sense that our atoms are just more stable when they have that full outer shell. Hydrogen only has that 1 shell, so for a full outer shell it needs 2 electrons there. So each of these atoms is missing 1 electron to make up a full outer shell. And the number of electrons missing, so the number missing, is equal to the number that they will then share. So the number missing equal to the number shared. So each of these atoms will share 1 electron, and we draw them with 2 overlapping shells, and those shared electrons, the dot and the cross, in the middle. That is our covalent bond. Each atom now has 2 electrons in its outer shell, and that charge is going to hold them together. Let's have a little look in more detail at why that is bonding them together. So we have in the nucleus the proton, that positive charge in there, and each nucleus has that proton, so they're getting a positive charge. And then in that space where they're sharing the electrons, we've got the negative charge. So similarly to what we were talking about with the ionic bonding and magnets, the opposites attracting, we have this attraction between the nucleus and those shared electrons, and that is a strong electrostatic attraction. Okay, within that covalently bonded molecule, we've got a really strong electrostatic force of attraction that's holding it together. Now let's take one more example. We've looked at hydrogen gas. Our next one is going to be oxygen gas. So first step, we need to write out the chemical formula. Oxygen gas is O2. That little 2 telling me that I've got 2 atoms of oxygen. Only thing I'm going to do slightly differently now, we don't need to draw out that full atom when we're looking at covalent bonding. We're only interested in the outer shell of electrons. So even though oxygen is in period 2, so I know it's going to have 2 shells, I'm actually only going to draw it, so I'll just write oxy so it's clear, with 1 shell, and I'm going to fill in that as its outer shell. I know there's one below with 2, but we don't need to include it in this. So let's just put in, it's in group 6, so 6 electrons in the outer shell, and I've got 2 atoms, so I'll just draw one more. 1, 2, 4, 5, 6. Now remember, the number missing means that is the same as the number that they're going to share. So we want 8 in an outer shell. We've got 6. So if we've got 2 missing, that means there will be 2 shared. So each atom will share 2 of its electrons. So I now draw my 2 overlapping, and then I put in the 2 electrons each of them share. I can fill in the rest around it. So each atom still has the same number of its own electrons, but it's now got a full shell because they're able to share those ones in the middle, and that charge is holding them together in a really strong charge. What we've got different from our last example is we've got 2 pairs of electrons in there. We'd call that a double covalent bond because there's 2 of them, 2 pairs. Okay, our first one was a single covalent bond because it just had single. Alright, so when you're doing this, you just need to follow these steps. Look at the formula, write out the atoms that you have, draw those atoms, see how many each atom is missing from its outer shell. That will tell you how many they need to share. Draw them overlapped and put in the number that each one needs to share. That will give you your covalently bonded molecule. Okay guys, so have a go at embedding that. Rewind back, watch it another time, take some notes down this time, self-test yourself on those notes, make sure you're confident with that process of being able to draw those diagrams, and get someone to quiz you before you move on. Right, I'd like you to have a go at these independent practice questions. Make sure you're checking that little chemical formula. So as you can see on fluorine, it's F2. So that little 2 is telling me that I've got 2 atoms of fluorine there. Here are your answers. Okay, hopefully we're happy with all of those. If you weren't sure of anything, rewind, watch it back, but that's all for today. Thanks for watching, guys.